To prove that an equation is an identity, you need to alter one side of the equation until it is the same as the other side. So pick a side, work on it, and then get it to match up with the left side of the equation. So these are actually kind of fun. It's kind of like a puzzle almost. You don't always need to do it the exact same way that your friend did it, and you can still come out with the same answer, right? Which is fun. Oh man, that's fun. All right, so secant of theta equals cosecant of theta times tangent of theta. Me personally, I'm going to work on the right side of this equation. So let's think of cosecant. It says here that cosecant is 1 over sine of theta. So we'll say 1 over sine of theta, and then it's being multiplied by the tangent. So if we think of the tangent, if you look here, it says tangent is the sine of theta divided by the cosine of theta. Sine of theta divided by cosine of theta. Now remember, when you are multiplying fractions, you can simplify stuff, cancel stuff out if it's in the numerator and the denominator. So with multiplication, it doesn't even need to be in the same fraction. It can happen diagonally, like the sine of thetas will cancel out here. So we're just left with 1 over cosine of theta. And then if you look and you're like, oh, the reciprocal of cosine, where do I have it? Oh, there it is. 1 over the cosine of theta is equal to the secant of theta. So we'll say secant of theta. Oh, well, look at what we had to get. We had to get secant of theta. So we ended up with secant of theta equals the secant of theta. Perfect. We proved it using our other trigonometric identities. Okay, let's try another one. Scoot this chart up a little bit. Cosecant of negative theta equals negative cosecant of theta. Now, we don't have any negative angle identities for cosecant, but remember that cosecant matches up with sine, right? It's the reciprocal. So we're going to be getting it into sine first. So cosecant, the reciprocal is sine, so we could say this is equal to 1 over the sine of negative theta. And then we could say, oh, snizzap, we could kick the negative out in front, so it'd be like 1 over negative sine of theta. And then we're like, well, if we bring the negative to the front and we have a negative denominator, then the whole fraction is negative, right? So it's like negative version of 1 over the sine of theta. Cool. And then 1 over sine of theta, that's the definition of cosecant. So we can say that's negative, and then the parentheses comes out to the cosecant of theta. So I know that so that was what we were trying to prove, right? We were trying to get it to the negative cosecant of theta. I know initially these probably seem very difficult, and it's just a matter of practice. You get used to this, using the same properties over and over. So it's daunting, but you can do this. Let's keep practicing.